Remember I had a friend who I know anything to say
It's a skill down. It's not all the way down to the maybe the boards are coming in 2 weeks. So basically, that's what it means.
No garlic. No butter. Sour, no sour. I don't know. I think so.
In addition to this,
There is good.
and then you can
That's something I'll write down.
there's 3 or 4 cutters, there's 3 there's some markers in place. So it's all
Yes.
But yeah, maybe in a month the boards are going to be made in 2 weeks.
Are you doing a presentation at all? Okay. Just have an old Sierra Club label on it. It's something you found.
This was the last thing I was at.
I thought it might have been something that Chris found surplus.
It seemed useful. I think you should have your interests tattooed on your forehead.
On the other hand, there might be some people whose interest you would not want to exist.
I know enough to run
All right, hello everybody. We'll get started here after a pretty good class. If you haven't been here before, welcome to Sector 67. We do these monthly meetings as a show and tell. Essentially, people take 7 minutes to talk about a project or a thing that they're working on. I think we have 4 or so presentations tonight, if I remember right. And then after the meeting, we'll go around and you can say who you are, what you're interested in, or why you're here otherwise, and we'll go from there. So without further ado, Mr. Marker is going to take it away. I've been harassing him for I think 3 months to talk about Fusion 360.
3 months to 6 years. I'm Mark. I mostly hang out here, but when I'm hanging out, I'm hanging out in the corner. Chris, dig into the Python API, which would be an applied program interface or something. So Fusion 360 is an Autodesk product. It's not quite free, but it's pretty open. Autodesk, I've been using Autodesk since like 82, 83. So one thing, it's not open source software all the time, but they do a good job of pushing software out to students. So that's one of the places where I know there's a big push to use open source software, and I truly believe in it, but Autodesk is fine with me for a couple of different reasons. I'm going to see if I can run President, which I think is...
There's a little carrot at the bottom.
Look at that.
Otherwise, you might use
All right, so there. This is, it's not open source, but Autodesk is not evil. So, and what it's a parametric modeler, so it's akin to it runs on the web, and it is it started out probably 6-7 years ago. It had four or five programming languages they were pushing out through some JavaScript, C++, and Python were amongst the three, and they pulled it back right now to just the two that I know of, C++ and Python, which is kind of a smart move on their end, I think, because they can only maintain so much. And that's a big thing for my crux of getting into it was to try to use transferable skills. I've been doing drafting stuff for quite a while, but it's nice to learn to do things one way, and that typically deep down underneath is math, which is what I also spend a lot of time fascinating on, now that my kids won't listen to me anymore. But and so Python allows us to do that. So that was kind of the crux of me going about doing this. What I made, I could have just downloaded from Thingiverse. That would have been too much work. So you'll see in the end product was not it was more the journey that I was interested in. And the reason for doing this is to let the benevolent dictator head off, stop giving me grief for just using SketchUp. One of the great things about here is you get gentle pushes by people doing different things. So there's a lot of people that use SketchUp, but most of them move on to something like Fusion 360 because it's much more buildable, as we see what people do. This has a lot of uses in terms of transferability, because Python has become a thing for quite a long time now, and the world is kind of grumbling behind it. I think amongst me, when I was trying to push people into Python, I think George Lucas used it at his lab, and then people were like, oh, okay, I guess it's okay. It's pretty much mainstream now. I don't know when it became mainstream. When did Python become? Because we learned Fortran, or some other Fortran.
It was after that.
It was after sometime after that.
Somewhere between 1916 now.
So, and for the other part of the API in the Python is I spent a lot of time on SketchUp, and I got into SketchUp mostly because I was teaching AutoCAD, and AutoCAD wasn't free, and SketchUp was free for quite a long time. And so the underpinnings of SketchUp and SketchUp physics is Ruby, and Ruby and Python, to people who don't know what they're doing, look a lot the same. So this is all the idea of making stuff transferable. And then I give a plug here to the original Apple Grapher, which is, on most Apple computers, it's a way to visualize really easily, really cool math with the minimal amount of things. So that was all my goals here. Basically, when you talk about a lot of the engineering software, whether it's SolidWorks or FreeCAD, which is where a lot of people are heading, it's about parametric models. And parametric models, basically for me, goes back to parametric equations, which at the very basic level is things as a function of time is the most normal way it's usually presented. And then when you want to move things around, parametric transformation. So this is all, again, not about the part. I spent most of the time in this trying to move things around in animations. That was my goal. And then for me, again, I spent a lot of time doing a lot of different things over time, and one of it was pushing early education adopters and learning linear algebra off the web poorly. But for me, I like the tagline on the bottom is one of my taglines of all, best taglines of all time. E to the I pi plus 1 equals 0. If that doesn't blow your mind, you have no soul or something. That's a quote from Sal Khan when he started doing his stuff, which is now pretty mature, 10 years down the line. But as I started, that was one of the places where you could go and learn stuff on the web. So to run the API, you need basically a computer, right, to run Fusion. And in the end, in the middle of this, you also needed to have Visual Studio, which is a download. They started with another kind of programming interface, and that just switched over about two months ago. It's not quite there. So one of the things you really want to do is to be able to debug stuff over here and have it work over here in the Fusion engine, but it doesn't work yet. At least I couldn't get it to work. But you can see people are working on it. That you actually have a debugger.
And that's actually Visual Studio Code, the free one, right?
Yeah. Yeah, Visual Studio.
Yes,
Yes.
Visual Studio is also a commercial desktop app, and VS Code is the more web-based.
Yeah, it's
free one.
it's a free one, and you can see they did the movement, and not everything quite works, but you know, you can see from the blog posts people are trying to get it work. So, in terms of the takeaways, in the end, at the very simple, if you control those three things with a minimal amount of code, you can get it to do a lot. However, it's got I spent a fair bit of time installing against the block that it uses some standard way in terms of debugging stuff. You're spending a lot of time with just a little bit of code just to keep track of this. Basically on the left is the way the number 1 looks like. It's a 16-place matrix, and I've spent enough time in Ruby that looks perfect to me. And over on the right, it's a twist of 45 degrees. And you start to recognize that. You only have to show a couple numbers and people get it. It's you know, you're changing a couple sets of numbers. Usually it comes and it travels, and if I can program better, it travels like here in 4 stacks. That's the location. And that's usually when you see it. I think this is a typical software. So again, trying to keep things transferable. I don't know why AutoDesk turned it around a little bit, but again, there was a month of my life. So once you end up doing that, you kind of set things up, and then you can. This is what typical code looks like inside the program. And what you're saying is your beer can or soda can is here, and it's twisted a certain way, right? And that's basically all this code is just twisting it around. And so if you can control that at the core level, it works the same in most programming, at least from my estimation. But because it's me, I'm always cycling back to SketchUp, because that's my brain. And so the code starts to look exactly the same between Ruby and Python. And my hope is that it's going to look the same with FreeCAD and with, what's the one that Shira does?
OpenSCAD.
OpenSCAD and then Blender. My really hope is that this works the same in Blender. So, and typically I think it does. All right, so all that said, this is what came out. Again, go to Thingiverse, right? But essentially, this is just a set of repeating shapes, or it's just one equation. This equation here, right, is basically a circle going up. So this could be e to the I pi or e to the I theta. So that's how short this code is, right? And the idea of parameterizing, I did not think that this would print, because as far as I know, what is it, 45 degrees, you're not supposed to go more than that, right? And I went less steep, and then I worried, and it came out. So, but the idea so I won't really do much live here except for figure out how to hit that and show you. The takeaway I had from this, amongst other things, is that there's no way I was going to get and completely code something up. But using this interface to like bring in a shape, the low-hanging fruit on the API is to basically bring in a bunch of points. And so it's a pretty typical thing to push out 3D points from other software in just a flat file, you know, whether you're doing it with locations. But if you can push out a bunch of points, you can then bring in, what kind of mouse? So basically, that's essentially the start by a couple of, in the last terms of the early entry, and I'll try to pull some of this code. I did a lot of animations, but I didn't know how to pull them up. It is. So this, in fact, is where things are started to be stored in parameters, right? So this is the software. You don't have to do what I wanted to do here, you didn't have to do it through the API at all. You can go straight into the program and set up parameters, right? But what you see here is really odd. Sketch up everything. Centimeter, which is pretty. The code, it's all based on that. And in fact, here I basically have a 1 centimeter box, which would be a unit box. And so this is as easy as it gets, and you start building as you add more and more components, more and more things fill up. But you can always then assess these things. You see the good programmer giving things the right name, and then down here me getting lazy, just letting things drop. So that's the other thing when you're I think programmers learn early to name things correctly. That's why I'm still, doing basic civil engineering. I didn't get this easily. So I'll go ahead and pass these around. $2. Is that what these were? No. I think in terms of, I took I usually print little tiny things because I know it's cheaper. So I think this is about $2 of stuff. It was 47 grams times 5.5 cents, so it's just around $2. And for me, it was like, okay, I guess that's why I don't print stuff. That's a bus ride. So, and of course, then if you're smart about it, and the fun thing is, this doesn't work. Scaling things down late at night, you make it half size, and then you make it quarter size, and then of course things start to usually fall apart. But I was pretty lucky, to kind of bring it down to quarter size. And as you're bringing things down to quarter size, they're getting 16 times, is it weaker? 16 times weaker? No, it's 4 times 4 times 4. Right? If you make something half, 1/8 is big. So that's 1/8 the cost. And then you bring it down to half again, it's an 1/8. So the little ones are only worth like 10 cents. Any questions? So it's a good, it's again not free, but you can get a license, a personal license. Okay.
So it looks like the primitive in Fusion was a swept thing that had a base and a swirl to it. Is that what that?
It can be. In this case, what I basically had the box. All I did was bring points. I was just using it as a tool to do the EDI. And then for me, that's how you go. I went about and then got into the software and did a little bit of changing code, and then. Used a patch. So the nice thing about with Infusion, if you have an odd shaped, closed shape, it will find a piece of cloth between it. That's pretty nice. So in terms of low-hanging fruit, you can get the cloth behind it, and then you can thicken, right? And then you can start doing stuff, and that's the process I did. So.
Any other questions? By show of hands, anybody? Oh, go ahead.
Well, so I know this was a adventure in Fusion for you, and so you talk more about Fusion than the 3D printing process. But I wonder what it would look like. I don't know if you've ever played around with like 3D slicing options. Traditionally they slice in a flat plane like what you see here, but you can actually get slicers for shapes like that will do a 3D slice. So that the extruder head will actually move in 3-dimensional space and map out. Yeah, we'll do that. And I've seen it mostly for shapes like that, and it can make crazy fast prints that don't have the later stuff. So I wonder what the process would be to generate a file from Fusion for something like that.
And I know Fusion I'm hoping that I can continue to use it to do more better machines, but I know Tormach, does a bunch of stuff with it. It has a lot of CAM stuff built into it. So that's what I know of Fusion. It's got a lot of, visualization and thinking through the CAM process. Again, all over the web, which is interesting. So, all right, well, thank you.
Eric, you want to go next? You're right up front.
This is from the school of how, not why, because what this is a spot loader for bicycle, e-bike batteries. And it's very simple. It just has a 12-volt ATV battery. The cheapest one that I could find, it's got 400 cold cranking amps, which may be too much. A solenoid, a starter solenoid here, that just allows me to control pulses that I send from my Arduino. I send it out, it's connected to the gate, and then the drain and ground are connected to the 12-volt battery. So, but with a 5-volt Arduino, I'm controlling the 12-volt. Lots of current. It allows me to make a weld. How many people here have torn a lithium battery apart and looked at the inside? Oh, really? That's all?
I pulled the cell out.
Okay, yeah, I'm surprised. I would have thought that as geeky as this place is, that nearly everyone. So I don't feel. I was wondering if I should even talk about this. So this is, what you recognize as a bike battery with two ends on it, and inside you get something that looks like this. Now, there's no danger here. This is completely flat, or we'd never do this if it weren't. But what goes on in here is you have a whole bunch of batteries that are approximately the size of a AA. They call them 18650, which means 18 millimeters by 65 millimeters. And if it's lithium ion, it's 3.7 volts nominal. And you can take it down as low as 3.2 or as high as about 4.2, but you shouldn't ever take it lower or higher than that, because then you begin to degrade the innards. They'll still take a charge, but they might blow up on you if you try to use them, because they might heat up too much, because they're inefficient. There's a lot of internal resistance, and that's a bad thing. They always have a little device here called a BMS, or a battery man here, that for the power, or for the positive, and the smaller wire for, a different color wire for the ground. And then each set of parallel batteries that you have here, this is built up by, you'll build up. This one is 4 by 10. So the nominal voltage is 3.7 volts times 10 in series gives you 37 volts, but they call it because each set of 4 parallel has to be in spec, or this thing will shut it down so that you don't have a bomb. That you're essentially riding on a bomb when you're on when you've got one of these babies behind you. But this is all very well understood, and these things do a great job of keeping it from going too low or keeping it from overheating. It also, the good ones will detect situations where things are overheating. Because if one of these cells goes bad in here, if you don't have the chops to take it apart and replace that cell, you throw the whole thing away. Now, the reason I got kind of interested in this is because I have a friend who worked at Crazy Lenny's when they first got started, and now he's got 3 bikes that he can't get replacement batteries for. And the quote was $600 per battery. It's dropped since then, but it's still a lot of money. So if you want to get into electric bikes, it would behoove you to learn about batteries and learn how to build up a battery pack. So I went through this. I'll just demonstrate. I also have these 2 wires. These are just 6-gauge cables that I bought at AutoZone. And the electrodes on the end are these roofing nails that I clipped the ends off, stuck them in and soldered them. I mean, it's really, I believe in making my prototypes as cheap as I possibly can. I have a switch here. Everybody listen. Did you hear that go click? Okay. There were actually 2 clicks there. The first click was a warm-up pulse, and everybody says you got to have a warm-up pulse, but I didn't, what for? Just, give it the juice. Anyway, it has a warm-up pulse, and then a delay, and then the welding pulse. And I went out and looked at places on the internet have, if your welding pulse is X in length of time, then this one place, he said, set your warm-up pulse to X over 9, so 1/9. Well, that seemed short to me, so I made it 1/5. So, is this too technical? Okay, so I thought, well, before I even attach this, I'm not sure if I've got the CMOS connections really, if I really understand that very well. So I'm going to try to operate this thing manually. So I wired this up, and I actually had a big automotive button because I didn't know how much juice I'd need to be able to send through it. The problem was it was too stiff. The spring was too stiff and it was too massive, so I couldn't get it down. Given the battery is fairly powerful, I couldn't get the pulse short enough. I kept burning a hole through the 2 pieces of metal that I was trying to weld. So then I went to a smaller switch, one this size. That's just a little momentary on, and I was able to get it down and get maybe every 5th weld would be good, but that's no good. You got to have all. After trying many, many times with this and sweating over, well, if I got this right for 3 weeks, I finally just decided, so I'll replace the CMOS if I blow it up. I'll replace my Arduino. I hook it up, and it worked great the very first time, which is the first time in history. However, before that, I went to AutoZone twice, and they sold me 2 bad solenoids. They'd probably been mangled and returned. And then I went to Farm and Fleet. It was the same story. That solenoid didn't work either. How do I know? Because if I hook it up to a 12-volt battery, it didn't click. So if you decide to do this, take a little 12-volt motorcycle battery with you and see if it clicks. If it does, you're in. If it doesn't, you're not. So it's important that, if you want to try to do this manually, just use the smallest momentary switch that you can find. Because you're just touching it, it's not, even though it's carrying quite a few amps, it's the load over time that's going to burn it up. It doesn't even warm it up, so you'd be good. But I don't see how these guys can do it by just holding the leads on there and touching it. I can't believe that they can get, consistent welds that way. So would somebody like to come and hold this while I weld something? Jim, you can do it.
Any glasses?
No. No?
Don't have ball in your mouth.
All right, it doesn't, I will do this. So, and I've got, these are dead batteries too, here, so.
Oh, Scott's got glasses.
Just as a for example.
Right, safety glasses?
Is your insurance up?
Yeah, exactly.
So if you just hold that there. No, I'm gonna.
Anybody want to get on a life insurance policy real quick with Scott?
While he's holding that, I splurged. So that I've got enough hands to make things work. So right now, the delay is set to the weld pulse, which is 35 milliseconds. So if you were to put that on the scope, would increase as you increase the welding pulse controls it. So you can might be able to. I'm going to pass this around. Just make sure you don't touch it, because even though it's a dead battery, you might still not like the results. So you can pull on this. You might be able to pull it off by hand, but my experience, I'm not very strong. So if you try it. be careful, this is a very sharp edge, do it on the flat. I'll pass that around. And if anyone else would like to try it,
Your ideal weld, so it doesn't
I
break
tried
through
shorter.
the
My first one was 31 millimeters. The ideal is you have the two metal, so it's not going to weld at all. If you give it too much, it's going to go all the way through. The current will go all the way through both layers and into the battery and then back out again.
Celtic, what is that doing?
I don't understand the metallurgy, but I've seen micrographs of it, and it this work with a single pulse. Weld a little bit, but I could pull it right off. So that was no good. As soon as I got a fixed timing set up to 6 different pulses, but the idea heat up, and if you do it over time, that's going to heat it up. That's actually going to destroy the battery and make it dangerous to use. So, any other questions? Yeah.
When you talk about the path the electricity takes, it seems kind of counterintuitive. You can run 12 volts and huge amperage through the battery.
Path is just going through the top and then back out again. If you have too much juice, it just blows a hole in it. And so I did a lot of testing with 2 strips together without the batteries. And then when I got what I thought was a decent.
What's the failure mode if you're welding poorly?
The resistance is high and it'll heat up. Or the resistance, yeah, it'll heat up, it'll fail, and the whole package could be damaged. Or you know, I can tell pretty much by looking at it and by peeling. You know, the big test seems to be if you can get it off by and peel it off. If the metal strip stays behind on the battery, then that's presumably.
Can you put a tester on there?
You know, I thought about that, and I went online and I thought, well, gee, maybe I should buy a milliometer so I can see what the quality of this is. And they start around $500, $600. I have no idea why they're so expensive, because if you just take two resistors and one, you have one that's say 220 ohms, that's your known, and then you put your unknown then you can calculate in milliohms what the resistance is. So that's a pretty sensitive. As these things now about $10.
Yeah, about.
The voltage. Buy something without knowing something about the electricity. Controller on Chris has one. What did you pay, Chris? About a couple hundred?
Yeah, they're a couple $100.
Yeah. I mean, it's not worth your while.
This kind of meta, can you make a welder out of lithium? You're using
Yes.
a lead acid battery.
Yes.
Seems kind of retro.
Yes, you can. But a double E friend of mine pointed out that you want to keep it around. I'd say you don't want to sit high. But my next thing is I'm going to just hook it up with my motorcycle battery and just. Or that may make do an inferior job, because it may
stuff is still a good honest. To give them wood that's an honest. My granddaughter's back.
If you're curious about, you can see the code itself, the Linux CNC configuration. Some scripts are using to customize that configuration. You know, if you want to get a sense for the project, and then on the wiki, documented the process of conversion. So there's a community of people that a long time ago I worked to convert those the Bridgeport class mills in the machine shop to a Linux-based system, and we documented that. And the community's made good use of that. Many other people have done those sorts of projects where there was a commercial analog control system that had like floppy diskettes and serial ports and all that good stuff. So other people have continue to make good use of hardware like that because they can run a modern, very sophisticated control system, open source control system. So we've taken for the limit switches that we all had to figure out. Jim, Chris, and I worked hard to figure all of that stuff out. There's a Z brake for the router, so the little pneumatic power at the head is heavy to just run down. So there's not to get too far in the weeds, but the motor control system we're using, normally you might spend $500 or $600 or $700 or $800 per axis to control the servo motor in a closed loop control system. The hardware that we used from Mesa was just bare H-bridge drivers, which I think was about $70 that control the feedback. That got a little more complicated, but we've been able to resolve those issues and cut parts successfully. So it's a banner day. We just cut that out today, and we'll be designing and cutting other spoil boards and still some things to wrap up. But all in all, it's going to be. We did have a prior, like a 4x8 version 1 ShopBot machine that was just the precision of it. We had problems. It was basically not accurate enough to do furniture and parts like that where you need things to fit properly together. This machine, because of the encoder resolution, it's going to be a very accurate machine for doing questions. Yeah.
With the dual motor gantry, if something did happen where a driver burned out or the software had an issue and those started skewing, is there any sensors or anything to prevent the machine from tearing itself apart?
Yeah, so in closed loop control systems, there's this concept of following error, which is the delta between your commanded location and where you actually are. And because we have encoder feedback, we can sense our following error. There's a threshold in software we can set move that would trigger the machine going to be stop speed.
Cool.
Interestingly, the ShopBot with steppers.
Machine is that you know when it's getting racked. Other questions? All right. Brian? Yes. Oh, Brian has questions. Sorry.
Were you able to use the HAL scope for the tuning?
Yes. You look at there's sort of a number of different locations, different forum threads and things like that that talk about the PID tuning process. In particular, stage drivers, there's different approaches you take depending on the kind of feedback you're getting. And so I haven't integrated any of the graphs yet, but there's a software-based oscilloscope that lets you graph the following error, velocities of the different drives and things like that. And I documented the procedure to do a pretty fast cycle. You're changing each of these parameters and then balancing out the system to get it to work properly and keep a really tight position where it's commanded. And so there's some really nice software tools that let you do that. So I was able to use the the HAL scope, they call it.
Brian and I might be fighting.
Is the pit tuning something that needs to change depending on whether it's under load or not?
Well, yeah, it does in theory. In theory, it would. In practice, even if we put more weight on the head, or if we have it's pushing through material, you should, to optimize it, you would change. But what we've done is we've taken a very sort of middle of the road conservative tuning. If we wanted to run this thing from one side to the other, and the X motors have to push harder if it is over on that X versus over on this X. So it's actually, even during normal operation of the machine, there's quite a different load between the motors depending on what's that cutting, for instance. But the parameters that we've got are conservative enough that it's well still within the range to control it. Which is why when you come back and say, I want it to go a lot faster, well, okay, that's going to be any other questions?
How long did it take to cut that part? Basically, once it started?
We ran it, I think we ran it ultimately about 200 inches per minute cutting. We could, what could go wrong? It was, I mean, maybe 15 minutes. It wasn't too long.
How long ago did you get the machine?
Oh, that's a painful question. It's 9 months.
Yeah, 9 months, that's like.
So it took 9 months, 10 minutes.
There was a lot of...
In my defense, we didn't start 9 months ago.
I was to say, we weren't moving at an expeditious pace.
Yeah.
So for reference though, for your hours you have in, if you went out to buy a machine of equivalent size and capacity, what's one of those run?
A good example is we took the old broken controls and sold them for $7,000. This machine new was about $150,000. So they're extremely expensive.
It was not intended to create industrial parts. It was sales things basically.
Yeah, otherwise, I'm sure Eric would be happy to make some.
So check it out.
I thought you offer help to carry it. Well, they're going.
Just move your body. Yeah, exactly. All right, Eric, you want to go?
Oh, yeah, I'm Eric Matthews. I'm a former member, and so haven't been a member since then. Maybe again in the future. I hope so. I diddle. I like to do electronics and software and whatever.
My name's Scott. I'm a member here. Hobby and machine control stuff, various interests, and now that we got this one on the run, next month you're going to see an insulation blowing machine. Blow your mind. So prepare yourselves. Yeah. It'll be warmer then, yeah. So. It'll be colder this summer. Yes.
I'm Dennis. I usually mess around with LEDs and Arduino projects, although right now I'm working on an audio project with 3D printed circuit boards. That maybe next.
Find me messing around with magnetic applications.
I'm Nick, I'm a member. My background's in aerospace engineering. My other interests are bikes, planes, woodworking, and games on time.
Max, chemical engineer and glass blower.
I'm Tom Garber. I'm a retired art historian. Live right near here, and I'm so impressed. I also like machines a lot. I've been involved at times with steam locomotives. And I'm so impressed with what Chris has done. And I've also worked in art museums and with a lot of contemporary artists. And Chris is very much like that. And I knew that when I saw this, that Chris had a great vision, but he didn't like to do paperwork. And he didn't like to sort those receipts. So I've come in here and I've given him some other suggestions, but basically I've started out by sorting receipts so he can get his money from the WEDC.
There's a matching grant that pays for 25% all the construction costs, and it's a big pain in the ass.
But he hasn't filed his receipts for 2 years, which means state money is just hovering out there.
It's plenty. It'll be there about 9 months once, even after you have all this stuff done and handed off. So it takes a while. So it'll be fun. But 2018, 2019, and then in time.
That's the same thing.
We'll have to get that yard on them.
Automating the science, so kind of nice. I'm Laura. A couple years ago, and I came and showed me the 3D printers when I was doing a project on that back in 2014 probably. So my background's also in biology and metabolic engineering, genetic engineering, but these days for my, I can't really see what you're doing with that. You spend a lot